Find the minimum y value on the graph of y is equal to f of x. Then state where the graph of f is increasing and where it is decreasing using inequality notation. Our function is given to us as f of x is equal to x squared plus 6x plus 3. Let's first of all investigate this problem with our graphing calculator. What we'll need to recall is that f of x is equal to y, so in place of f of x we can put y in its place. So on our calculator we'll sketch a graph of y is equal to x squared plus 6x plus 3. So first of all, locate y equals up in the upper left hand corner of your keypad. Press y is equal to and enter the expression x squared plus 6x plus 3. Once you've entered the equation into the calculator, you'll want to obtain a good viewing window. To obtain a good viewing window, go to Zoom and select Zoom Standard. Notice that the graph of the function is a parabola, and the parabola has a lowest point which is called the vertex. The minimum y value of the function will occur at the vertex. So we want to calculate the lowest point, or calculate the minimum value of the function. Your calculator has a built-in feature for doing that. It's underneath of calculate, which is second trace. So press second and trace to bring up the calculate menu. Notice that the third option is minimum. Either press the number 3 or scroll down to 3 and then press enter and then follow the prompts. The first prompt is for a left bound. So use your left arrow key and scroll until the cursor is to the left of the lowest point. Then you're prompted for a right bound. Use the right arrow key to move the cursor to the right of the minimum and press enter. Finally, you're prompted for a guess, so use the left arrow key to move to the lowest point, press enter. When you see minimum at the bottom of the screen, the calculator has calculated the minimum value of the function. In this case, the minimum value occurs when x is -3 and the y value is -6. So -6 is the minimum y value of this function. In part 2, we're asked to determine the values of x where the graph of f is increasing. Increasing means the graph is rising from left to right. So when you think increasing, you want to think of the graph as rising from left to right. So looking back at our graph, we see that the graph is rising from left to the right of the lowest point, to the right of the vertex. The x value of the vertex is -3. So the function, the graph of the function is increasing when x is greater than -3. Decreasing means that the graph is falling from left to right. So we look back at the graph and we see that the graph is decreasing to the left of the lowest point. The x value of the lowest point is -3, so the graph of the function is decreasing when x is less than -3. We were able to use the calculator to help us complete this exercise, but you should also be able to complete the exercise by hand. So let's just review a few important properties of functions that have the form y is equal to ax squared plus bx plus c. The graph of a quadratic function of this form will be a parabola, and that parabola will either have a minimum point or a maximum point depending on whether the parabola opens up or down. That lowest or highest point is called the vertex, and the notation that we often use for the vertex is HK. The vertex is equal to the point HK. The H is the x-coordinate of the vertex, and K is the y-coordinate of the vertex. In order to find the value of H, you take the opposite of B and divide by 2A. In order to find the K value, you substitute the value of H into the function. So you just find f of the H value. So for this particular function, we have f of x is equal to x squared plus 6x plus 3. The vertex will have the form hk. In order to find h, we'll take the opposite of b. b is the coefficient of x. In our example, the coefficient of x is 6, so we have the opposite of 6 divided by 2 multiplied by a. A is the coefficient of x squared. The coefficient of x squared in our example is the number 1. When we evaluate, we get negative 6 divided by 2, which is negative 3. Negative 3 is the x-coordinate of the vertex. In order to find the y-coordinate of the vertex, we just substitute the value of negative 3 into the function. So f of negative 3. So we find the square of negative 3, add 6 times negative 3, and then add 3. The square of negative 3 is 9. 6 times negative 3 is negative 18. And then we add our constant of 3. 9 minus 18 is negative 9. Negative 9 plus 3 is negative 6. So the minimum y value of the function is the value of k, which is negative 6. Now in order to sketch a graph of the parabola, we can plot the vertex. In this case our vertex is the point negative 3, negative 6. So let's go ahead and graph that first. So we'll draw our x-axis. And our y-axis. First point we'll plot is the vertex. The vertex occurs when x is negative 3 and y is negative 6. So we locate minus 3, minus 6. Alright, now in order to draw the parabola, we need to locate some other points on the graph. My recommendation is to make a small table of values. So you pick some values of x and then evaluate the corresponding values of f of x. Now we already found that when x is equal to negative 3, f of x is equal to negative 6. One easy point to find is the y-intercept. The y-intercept occurs when x is equal to 0. When x is equal to 0, we get the square of 0 is 0, plus 6 times 0, which is 0, plus 3. The end result is 3. So we have the point 0, 3 on the graph. Now you might have noticed when we graph our parabola that it had some symmetry. If there's a point 3 units to the right of the line of symmetry, then there's going to be a point the same height, the same distance to the left. So 0 is 3 to the right of negative 3. If we go 3 to the left to minus 6, then the value of the function is going to have exactly the same height of 3. So if we go to negative 6, then we'll need to go up 3. And then now we can connect these 3 points with the shape of the parabola. And then once we have the graph of the parabola, then we can answer parts 2 and part 3. We see that the graph of f is increasing when x is greater than negative 3 and decreasing when x is less than negative 3. So I'll just draw x is equal to negative 3 on the picture. And we can see that the function is decreasing to the left of x is equal to negative 3 and increasing to the right.